Right. So essentially, we said that these components, the horizontal components and the vertical components, they're completely independent. They don't depend on each other. For the horizontal component, there is no acceleration, right? So there's no force acting in this direction, so therefore there is no acceleration in the x component, right? But for the y component, acceleration acts in the vertical direction. It is constant and equal to the acceleration due to gravity. All right, because of the force of gravity, and you can find the projectile at any given point, right, using the coordinates x or y. You can find it at any point at a particular time. All right. Now, the velocity of the projectile, which would be this particular velocity here. Now, this particular velocity is called a tangential velocity because it acts in tangent to the motion, right? Remember we spoke about tangent before, right? It popping up again, and in the tangent you will have your y component, and of course you would have your x component. This would be your v, right? So this particular velocity can be calculated from the components of the velocity at any particular point or instant on this path by using Pythagoras theorem, right? So you would calculate the velocity in the x direction, calculate the velocity in the y direction, and then you would use Pythagoras theorem, right, to find um, your tangential velocity. Tangential velocity. All right. Let me see if I'm missing out anything. Okay, good. We can move on. All right. So essentially, for Pythagoras, right? Let me fix this properly. Now you have your x component, Vx, or let's say yeah, Vx, and we have Vy here. Now remember the formula for Pythagoras theorem? What is the formula again for Pythagoras theorem? I want to find this here. V. Hmm?
A square plus b square equals c square.
Alright, so let's say that's good. So a squared plus b squared equals c squared. Alright, what would be c in this case? What would c be?
From the diagram, sir, that you drew, sir.
Yeah, this diagram. What would c be?
V.
Alright, so c would be v, and then a and b can be either, right? So let's say a is vy and b is vx. Alright, so essentially your formula will look something like this. V squared equal a squared plus, sorry, uh, v squared equal b vy squared plus vx squared. All right, so essentially your formula will look like this. Now, how will you go about calculating vx using the trigonometric functions? All right, so whenever we're dealing with whenever we're dealing with um, let me see here. No, let me. I need more space. All right, remember whenever we're dealing with trigonometric functions, you remember so all right,
Yes, sir.
all right. This is for sine, this is for cos, and this is for that. So we want to find this. We want to find v. That's what we're aiming to find. We're aiming to find this guy right here. I should arrange some more space. But essentially, let's try and work with this. All right. Yeah. So we want to find v. Now, in the x direction, is there any acceleration in the x direction? Yes. No. Let's go back to the slide. Is there any acceleration in the x direction?
No, sir.
All right. Good. So Vx, remember Vx is your final velocity in the x direction. Remember that? All right. I'm going to need more space. Let me just um, fix this. Fix this. Decode some of these. Let me see. All right. All right. So right. So we said that there's no acceleration in your x direction. So in the x direction, let me just write that down so that you remember. So no acceleration. So Vx is your final, and Vy and V0x should be your initial. So because there is no acceleration, V0x is equal to Vx. All right. Now because of this, right? Because of this, we can say therefore that your velocity in the x direction doesn't change. As a result, we can use the initial velocity v0, and this is v0x. Remember, we're trying to find this one here. We're trying to find the final velocity, right? But for the initial velocity, we can use that. Say they give us the initial velocity, we can use that particular equation to find our final velocity. All right. So therefore, which one would we use for to find v0x? Which one of the trigonometric functions relate v0 and v0x? Hmm? Oh.
Cos, sir.
All right. So cos, good. So cos theta is equal to our v0x over v0, right? v0x over v0, and we said vx is equal to v0x. So let's just put that down. So if I go ahead and say cos theta equal to v0x over vx, then that would give us for for sorry, v0 instead of vx. Right. All right, just give it a few seconds. It will make sense, right? Now, if we solve for v0x, we would get v0x equal to v0 cos theta. Remember, let's say the question gives us the initial velocity. We're trying to find the final velocity. We're trying to find the final velocity. Now, in order for us to do that, we have to relate the initial velocity to the final velocity. And the only way that we can do it in the x direction is to use this particular this particular relationship that states that the initial velocity in the x direction is equal to the initial velocity is equal to the final velocity in the x direction as well. And then we can also use the initial velocity, right, overall, right, times cos theta to find v0x. And we said v0x is equal to vx, so therefore vx is also equal to v0 cos theta. So we can take this and we can plug it here. All right, so we solved for one. So vx is equal to v0 cos theta. So we're trying to find this guy here. This is what we're trying to find. But in order for us to do that, we have to relate the initial velocity. Let's say the question gives us the initial velocity, right? We would relate that to our final velocity because of this equation here, because it doesn't change, there's no acceleration. All right, so is this clear? Yes?
Yes,
No?
sir.
All right, anyone doesn't understand? Please let me know if you don't understand. If you don't understand anything right here, just let me know. All I have to say is, sir, I don't understand. That's all. All right, so I take it that we understand then. Remember, you can interrupt me if you have any questions. All right. Now for the y direction, right? We want to find vy. We want to find vy. We want to find the velocity, right? Vy, velocity in the y direction, to be able to relate this to our final velocity overall. All right. Now, if we remember, there's a force in the y direction, right? And this force causes acceleration due to gravity. Now, because of that, we want to find we have our, let's set up our system here again. Let me see. For this is, we have the x and y components. Now, which one will we use now to find our initial, right? So let's say we're working with initial velocity. Let me not use that one. Let me use this one down here. Let me draw another one, not to confuse you. V0x and V0y and then V0. So they gave us, remember that they gave us this value. Let's say they gave us this value, and we use this to find our velocity in the x direction. Now, we want to find the velocity in the y direction. Which one of these trigonometric functions would we use now? Which one of these would we use? What time is it? All right, so we have 3 minutes left on this here. Which one of these would
Science,
we
sir.
use? Sine, exactly.
Mm.
So B0y, let me just put that on, sine theta is equal to V0y over V0. And if we want to find V0y, if we want to find V0y, we would say V0y equal to V0 times sine theta times sine theta. This would give us the initial velocity in the y direction. This would give us the initial velocity in the y direction. I think I'm going to need more space. Let me see. Let me make this smaller. Right. V0, V0y, sorry, V0x, V0x, and V0y. All right. So we now find we just found the component in the y direction for initial velocity. Now, if you remember from the previous, remember that we have the initial velocity in the y direction. Now we want the final velocity. That's what we want now. We have the initial velocity. Now we want the final velocity. And if you remember from the last class, right, where is that particular formula? Right here. Remember this? So we have V equal V0 minus AT. This is one of your equations of linear motion. All right, so you essentially just relate this to your y direction. Very simple. Vy, V0y times acceleration. Your acceleration is due to gravity. And then you have your time. Time doesn't change. So we just relate this back here. Let me put it here. So all this is your y direction here. So we said V equal V0 minus AT. We go to Vy equal V0y minus GT. All right, then that would give us, what is V0y? We just got it right here, right? What is V0?
V0 times sine
All right, so
theta.
V0 times sine theta minus GT. So essentially, we just plug that in here. All right, so we are out of time for now. So V0 sine theta minus GT. All right, this would give us your final velocity. V squared. And then, of course, if you want to find V, you square root both sides. Then that would give you V0 sine theta minus GT plus, sorry, let me place in a square here, V0 cos theta squared. All right, so that is it. For now, we will take a break. Um, you want to take the break and come back, or you want me to just finish this and then go up until 11:50? Hmm? Take the break. All right, so we'll take the break out then. I'll take that. Yeah? Yes, no.
Yes,
Yes,
sir.
sir.
Take the break. All right. All of us. We come back at 12:30. 12:30? Yeah, 12:30.